Okay, hello everybody. Thank you for joining our Young ISA webinar today. So I'm delighted that our speaker today is Rohan Alexander. He's joining us from the University of Toronto, where he is an assistant professor. So Rohan likes to use statistical models to try and understand the world. And I'm pretty sure he is in the process of writing a book about telling stories with data, which I'll be looking forward to reading. But today he is going to talk to us on the privilege of turning our world into data. So I'm really looking forward to this talk, and you can take it away, Rohan, whenever you're ready.
Thank you very much, Neve. So as Neve said, I'm an assistant professor at the University of Toronto, and I'm in the Faculty of Information and also the Department of Statistical Sciences. I'm also one of the co-leads of the University of Toronto's Data Sciences Institute and the thematic program on reproducibility. And we'd love to develop sort of ties with other institutions who are similarly interested in those sorts of reproducibility issues. So if you do have any sort of interest in those, please don't hesitate to get in touch. I'd like to thank Neve for the opportunity to talk today. I always feel a little bit awed by everything that she's able to accomplish and all of her publications. And in preparing for this talk, I was sort of looking for imminent historical IRIS statisticians. And of course, arguably one of the most imminent present day IRIS statisticians is Adrian Raftery, who had a PhD student, and Leontine Alkema, who was Neve's postdoc advisor. So Neve certainly lives up to her pedigree. I feel a little bit of a fraud talking at the Young Irish Statisticians group. I'm no longer young, I'm certainly not Irish, and I'm not a statistician, but I do adore your country. My child's first overseas visit was to Ireland, and I spend a lot of time with statisticians, and I was once young, and so I hope that in a few years, you can invite me back, we can do this in person, and we could have sort of a middle-aged Irish fans, pseudo statisticians group or something like that. Today I'd like to talk a little bit about the origins of data science, and I especially like to mention some of the earlier contributions by some of the Irish statisticians. I'll turn to what I see data science as and some of our roles and responsibilities as quantitatively interested folks. I'll go through a few applications of my own work. That's understanding the effect of elections, hate speech detection, and the reproducibility of COVID-19 preprints. And I'm going to focus more on what I learned and how I developed as sort of somebody interested in quantitative issues rather than specific results. And I'll close with a few sort of open issues and areas that I'd like to see some more development on. None of this is canon. It's not really a traditional academic talk, but I figured it was the end of the year. And so this talk is more my way of trying to work out what I think. So I certainly appreciate your reactions and comments. So what is data science? I think that when we think about data science, I think we all have different things in mind. I think that the only thing for certain is that there's no agreed definition of data science, but a lot of people have tried. For instance, Hadley Wickham says, and it's an exciting discipline that allows you to turn raw data into understanding, insight, and knowledge. Jeff Leake and Roger Peng say that it's a process of formulating a quantitative question that can be answered with data, collecting and cleaning the data, analyzing the data, and communicating the answer to that question to a relevant audience. Baumer, Kaplan, and Horden say that it is the science of extracting meaningful information from data. And Tiffany Timbers, Campbell, and Lee say that they define data science as the process of generating insight from data through reproducible and auditable processes. Radu Creu, who is one of my bosses, he argues that the lack of certainty as to what is data science might not matter, because who can really say what makes somebody a poet or a scientist? He goes on to say what makes a data scientist is somebody who, with a data-driven research agenda, who adheres to or aspires to use a principled implementation of statistical methods and uses efficient computational skills. And regardless of who is right, alongside those specific, reasonably technical definitions, I think there's value in having a simple definition, even if we lose a bit of specificity. For instance, we often informally describe probability as counting things. And so in a similarly informal sense, I think that data science can be defined as something like humans measuring stuff typically related to other humans and using sophisticated averaging to explain and predict. And that might sound about touch cute, but Francis Edgeworth the Irish 19th century statistician who went to Trinity College Dublin, considered statistics to be the science of those means who are presented by social phenomena. So I think that it is in good company, especially among this group. In any case, one of the features of this definition is that it does not treat data as terra nullius or nobody's land. Statisticians tend to see data as the result of some process that we can never know, but we try to use data to come to understand. Many of us probably teach those sorts of definitions. Lots of statisticians care deeply about the data and measurements, but there are also many cases in statistics where data just kind of appear. They belong to no one. And that's a very painful process to see, because that's never actually the case. Data need to be cleaned and gathered and prepared, and every decision in that step matters. Each of those steps matters. I think that every data is sui generis. I think it's a class by itself. And so when you come to know one data set, all you know is one data set, not all data sets. More broadly, I think that much of data science has focused on the science. And I think that it is important that we turn to data. And I think the reason that it's focused on science is because that's the easier bit, and that turning to data and focusing on data is extremely painful. And I think that that's another feature of my cute sort of definition of data science that I argued before, because I think that a lot of data scientists are generalists who are interested in a broad range of problems. And often the thing that unites them is the need to gather, clean, and prepare messy data. It's often the specifics of those data that require the most time, that update the most often, and that are worthy of our most full attention. However, I don't think that it's the type of thing that is professionally rewarded at the moment. At this point, I'd like to look back for a moment at the origins of data science. I think that if we look at the history of statistics, we very quickly find ourselves surrounded by Irish contributions. And when I was preparing for this talk, I was thrilled to learn about the book by Reverend James Whitelaw. And this is the actual title: An Essay on the Population of Dublin, being the result of an actual survey taken in 1798 with great care and precision, and adopted and arranged in a manner entirely new. And I think that maybe all of us need to sort of adopt a little bit more of Whitelaw's detail in our paper titles. Neve, Monica said that perhaps Leontine had been inspired by some of these, the specificity in these titles.
Yeah, she definitely goes for the longer titles for sure.
In any case, so reading Whitelaw, this book from 1798, he says that he's fed up with bad estimates of the size of the population of various capitals, and he particularly singles out estimates of the population of London. And he says that these have estimates that range anywhere from 128,000 through to 300,000. And he says, look, this is not good, and I am going to make an accurate count of the number of inhabitants of Dublin. He describes how when he first enters, and I'm quoting, when I first entered on this business, I conceived that I should have little more to do than to transcribe carefully the list of inhabitants affixed to the door of every house by order of the Lord Mayor. So the mayor's going to go and he's going to order all of the inhabitants to write down all of the people in their house, and he's just going to go and collect these. So, and like many of us who spend our days in data, he found that it was not that simple. He found that the lists on the door, and I'm returning to a quote, presented generally to view a confused chaos of names. They were frequently illegible, and they were generally short of the actual number by a third or even a half. He goes on to say that instead, he and his assistants braved the dread of infectious diseases, filth, stench, darkness to explore every room of these wretched habitations, from the cellar to the garret, and on the spot ascertained their population. The resulting table looks something like this. In case you're interested, his estimate of the total population of Dublin in 1798 was 180,000. And the estimated population these days is a little over 500,000. One thing that I was surprised by was how confident he was in his numbers. So as I said, I'm not a statistician. My PhD is in economic history, and I was very interested in Australian economic history, especially political history. And the thing about economic historians is that we have to create and clean and prepare our own data sets from whatever traces of data we can find before we analyze it. And that really trains one's mind on measurement and sampling issues, which of course statisticians have very well developed processes around. But there's an odd phenomenon that I've observed where the further one is away from the decisions to count and measure and organize and categorize, the more one tends to trust the resulting data sets. That is, the person who does the actual hard work of constructing the data sets is usually the one that trusts them the least. And I've never understood this confidence that people have in data sets that they don't construct themselves. It's an absolute privilege to work in data science, to be able to feel like the Reverend did, that one is bringing some order to things. But I think it's important to realize that the perspective that one brings as one is doing that. And my point here is not to attack Whitelaw. He's long dead and he's completely incapable of defending himself. But I skipped over a bunch of the actual quote in the book, okay? Because after he talks about that bit about going to look at the lists on the doors, remember he thought that he was just going to go to the Lord Mayor was going to convince everybody to just put a list of their inhabitants on the doors. After he talks about that, he says, as the families of the middle and upper classes always contain some individual who is competent in their task, and as few had motive to conceal or misrepresent, I found their lists were extremely correct. But among the lower classes, which forms the great mass of the population of this city, the case was very different. This I first thought was due to design, but afterwards I decided that it proceeded from ignorance and incapacity. My question is, like, how could he possibly know that? There's no way. As statisticians, as people interested in data, to a certain extent, of course, we know that we're wasting our time, right? We have a perfect model of the world. It's the world, okay? The issue is that it's too complicated. If we knew how everything was affected by uncountable factors that influence, then we could perfectly forecast coins. We could perfectly forecast dice and every other seemingly random process, but we cannot. Instead, we have to simplify things to that which is plausibly measurable, and it is that which we then define as our data. But it's important to recognize that our data is simplification of a messy, complex world from which they were generated. I think that there are definitions of plausibly measurable. And so our data sets are always the results of choices. And our decision as analysts is we have to decide whether they're reasonable for the task at hand. We then use statistical models to try and help us think deeply about, explore, and hopefully come to better understand that data. And much of statistics is focused on considering thoroughly the data that we have. And that was appropriate for when our data sets were predominantly agricultural, astronomical, or from the physical sciences. But I think that the rise of data science has been mostly because of its value in applications to data sets generated by humans. So we must actively consider who is not in our data set, who is systematically missing from our data sets, whose data does not fit nicely into the approach that we are using and hence is being inappropriately simplified. And if the process of the world becoming data necessarily involves abstraction and simplification, then I think that we need to be clear about the points at which we can reasonably simplify and those at which it would be inappropriate. And for this reason, I think that data science needs diversity. And this is one reason that I'm excited by all of the initiatives to sort of increase participation by women and young people and other underrepresented groups, such as your group. I think that we need our labs, our classrooms, and of course, eventually our startups, which, Dublin, I am aware, has a very thriving startup business, our startups and our businesses to be representative of broader society. As I mentioned before, I think that those who do the measurement and are deeply immersed in the details have less trust of their data than those that are removed. And I've found in my experience that even seemingly simple tasks such as measuring distance, defining city boundaries, and counting populations are surprisingly difficult in practice. Now, I'll provide one example of how something that seems really simple quickly becomes difficult, and that is maternal mortality. Maternal mortality is the number of women who die while they are pregnant or soon after a termination from a cause related to the pregnancy or its management. It's difficult but critical to turn this sort of tragedy of a death into cause-specific data, because that helps us mitigate future deaths. Some countries, such as Ireland, of course, and Canada, where I am, have well-developed civil registration and vital statistics. So these are CRVS, Civil Registration and Vital Statistics. Now, these collect data about every death. Even if a death is recorded, defining a cause of death can be difficult. And we've seen this with the COVID, with all of the COVID cases. What did the person actually die of? And this is especially the case when there is a lack of qualified medical personnel or equipment. Maternal mortality is an especially difficult case because there's typically many causes. You might die of a heart attack. That was an implication of this. And some CRVS, some of those civil registration and vital statistics systems, have a checkbox on the form to specify whether the death should be counted as maternal mortality or not. But even some developed countries have only recently adopted this. For instance, in the US, it was only introduced in 2003, and as recently as 2015, Alabama, California, and West Virginia had not adopted this sort of standard question. We just have no idea about something as simple as maternal mortality. I mentioned at the start of the talk that I'm appointed in both the Faculty of Information and the Department of Statistical Sciences. And for those of you who don't know, faculties of information were created at around the turn of the century to train librarians. Library science, of course, has a long and distinguished history of archiving, categorizing, storing, and retrieving information. And for a long time, when computers were first developed, a lot of this initial work was done by librarians or at libraries. I suspect that there's a gendered aspect to this, with librarians often being female, but a lot of that work was systematically overlooked and was subsequently reinvented later. And this continues today with our library at the University of Toronto, consistently doing excellent work that is consistently overlooked. And I used to feel a little bit funny about being jointly appointed. But as I prepared for this talk, I learned that the first chair of the Department of Statistics at Trinity College Dublin, Gordon Foster, was not only a statistician, but he also created the International Book Numbering System, ISBN, which we still use today. In 1968, Foster gave the Geary Lecture at the Economic and Social Research Institute in Dublin. And I'd like to revise some of the points that he makes in this talk. So remembering this is 1968, because he was clearly yet another Irish statistician who was well ahead of his time. Foster describes, and I'm going to read out the quote, "Just prior to my time, when my own career in statistics was commencing, an important development took place in which I was therefore able to participate straight away, and which has since had a great effect on the development of the subject. And I mean, of course, the invention of the computer." And it's funny, but I think that 50 years on, I actually feel exactly the same way about my career. I feel like all of this stuff was only just invented, and it's just allowed me to go on. Foster actually goes on to say that it was something of an achievement to get a program actually working. It was useful to have a screwdriver and some Scotch tape and to know where to kick the machine if it's stuck. And again, as somebody who has the privilege to write code for a living, I do wonder if much has changed 50 years on. It's interesting that Foster points very clearly to data science in this talk. And probably all of you have read this talk, but it was new to me. If you've not read it, it's worth revisiting. But he says, statistics are concerned with the processing and analysis of masses of data and with the development of mathematical methods of extracting information from data. Combine all this activity with computer methods and you have something that is much more than the sum of its parts. Talking about computers at the time, he says, and remembering this is 1968, right? He says they're capable of performing any structured task. They can plan a hospital diet. They can retrieve a legal precedent. They can control stocks in a warehouse. And they can even play a reasonably good game of chess. And I think that we're beginning to realize the endeavor that I have just referred to as technology. This is Foster speaking. Information technology is no longer something that only affects specialists, but is bringing about changes in society that affects us all. That's the end of his quote. How easy would it be to change information technology to data science in that quote for them to sort of ring true almost a lifetime after they were first spoken? We've always used various instruments to turn the world into data. For instance, in astronomy, we have these new telescopes and eventually satellites and probes, and they're developed and they enable better understanding of our world, of other worlds. And similarly, we have new instruments for turning our own world into data being developed every day. For instance, as I mentioned, my training is in social sciences, and once in social sciences, a census was sort of a generational defining event, right? And it's appropriate that this talk sort of happens near the Christmas holidays, given the role that the census played in that event. But we now have sort of very regular surveys. We have transactions data available by the second. One of your Irish sort of sons, Stripe, just makes unimaginable data sets available on transaction processes. Almost all of interactions on the internet become data of some kind. And the development of those instruments has enabled exciting news stories to be told with data. But I think that in the past 10 years or so, we've had the balance a bit wrong in data science. I think that there's been too much focus on the science bit without sufficient focus on the data bit. And I think that it's not just the science bit is hard, it's the data bit that's hard as well. I feel that Foster would have known this and that we're just reinventing things. For instance, researchers went back and they examined one of the most popular text data sets in computer science, and they found that around 30% of the data in that data set was inappropriately duplicated. There's an entire field, it's called linguistics, and they specialize in these types of data sets. And inappropriate use of data is one of the dangers of any one field being hegemonic. Statistics, I think, has a lot to contribute here, but I think that we maybe need to be a little bit stronger about how we make our contributions. The strength of data science is that it brings together folks from a variety of backgrounds and training to the task of learning about some data set. It's not constrained by what was done in the past, but I think that this means that we need to go out of our way to show respect for those who do not come from our own tradition, but who are nonetheless just as interested in a data set or a specific question as we are. I picked on CS a little bit here, but my home of social sciences is just as bad, and researchers like me are trying to refocus us a little bit on data a little bit more than we have been in the past. So I'll go through a few examples of work, of my own work. So I mentioned that my PhD is in economic history, but I spent most of my PhD trying to deal with big data sets. And when I say deal, I mean using R to clean and tidy them, and that turned out to be the work of years. One of the results of that work was the paper, The Increased Effect of Elections and Changed Prime Ministers on Topics Discussed in the Australian Federal Parliament. And that was co-authored with my wife, Monica. So in Australia, as there is in Ireland, there's a written record of what is said in Parliament, and we call it the Hansard. And so what Monica and I did, we grabbed the text of everything that was said between 1901 and 2018, and then we built a statistical model to look at whether the topics of discussion, so what was being talked about, changed after there was an election or after there was a change in the Prime Minister. And what we found was that changes in Prime Minister tend to be associated with topic changes, even when the party in power does not change. And that the effect of elections has been changing since the 1980s, regardless of whether the election results in a change in Prime Minister. The main lesson from that work was always start small and iterate. So I came into that paper, I was hopelessly naive and I was hopelessly lost. And I didn't know that text analysis or natural language processing more general was something that was already incredibly popular. I didn't have the skills that I needed. I didn't have, all I had was an all-consuming interest in the broad area. The data set turned out to have over 1 billion words. And so the main lesson for me was in dealing with big data sets. And here I don't mean technical skills, I mean approach. And I think that this is something that we can be a little bit better about teaching our students. These days when I have students and they want to use Hansard or any large data set, I always start by insisting that they just use 1 week or maybe 1 month of data, not a century. And they analyze that, and then they write that up, and then they go to a year, and then a decade, and they continue to build this up slowly. And the reason that I now know that that's the best way to go is that I convinced myself during my PhD that I couldn't possibly answer any interesting question until I had a century worth of data. And that, of course, took years to get into a usable format. one thing that I think that we can take away from startups is this creation of this minimal viable product in research. And I think that that's something that we can be a little bit better about teaching. I think that that minimal viable product should be something that you can finish within a week, and that we should teach our students to adjust the scope and the question until they can get to something that can be done a week. And you achieve that MVP, and then you scale up until the question is that you're interested in. And hopefully, you know, if you're in our world, you get something that can be published, and if you're in the startup world, then you get something that, you know, turns into being Stripe or one of your other Irish success stories. The next one that I'd like to talk about is GPT-3, and here I'm going to do some live coding. Okay, so I'll just set this up. Actually, I'll put this here, so just to set this up. So as anyone who has cared for young children know, the response to almost any statement can be why. You know, and you quickly sort of find yourself trying to explain the finer details of photosynthesis to a 3-year-old, and the extent to which one struggles with that, you know, tends to put one's knowledge into sort of, you know, sharp relief, and it can be scary. But we have these large language models, and an example of this is this one that I'm sharing here. It's created by a company called OpenAI, and it's called GPT-3. And these large language models, they can generate text that is indistinguishable from that is created by humans. And I'll provide an example in a moment. They can also classify, and so if they can do that, then they can say that they can generate racist and sexist text, right? Because humans can generate racist and sexist text. And so the question in this paper was, well, given that they can given that they can generate racist, sexist text, can they classify racist, sexist text? So here, I'll give it an example, just so that you can see what's happening. Okay, so down the bottom here, so this has been trained. It's been trained on essentially the whole of the internet. And what you do is you give it a prompt. Okay, so let's just say, what is the population of Dublin? And we know what the answer should be, right? I'll move this up so that you can see it a little bit better. Sorry about that. Okay, and we're going to generate, and we're expecting an answer that's around about, I thought we were expecting an answer that's about 500,000, but there we go. So we might be wrong. Let's regenerate and see if we get 1 through 1.3. So I wonder if there's some odd definition thing that's going on here. But anyway, there we go. And so what we found was that GPT-3 was not very good actually at working out whether some text was
I think that's actually right. I think 1.3 million is right.
1.3 is right. Okay, right. Oh, very good. Okay,
or
so
like ballpark. Yeah, I think it is. I think because I just Googled it there quickly. And like 500,000 comes up, but that's 2016 for something.
Okay.
Yeah.
So it's just like rapid growth. This is why you manage house prices. The Dublin house prices are outrageous. Okay, so this is an example of what we asked. So we said, is the following text sexist? Answer yes or no. The thing is, women are equal to us men and their places in the home and kitchen. So we grabbed these from Reddit. And I mean, this is clearly sexist, right? So let's see what it says. No. Okay, so I mean, you can see the issue here, right? It's been trained on the internet. And in this case, GPT-3, beg your pardon, OpenAI, they flag this. They say, look, this contains sensitive information. You know, you shouldn't necessarily rely on this. So they have put in place steps to sort of mitigate the reliance on this. Let's regenerate it once more time. Let's see if we get a different answer. Yes. There we go. Okay, so this time we got, so what's underpinning this? This is it's just a massive statistical model. So we're just getting, all right, one more time, and then we should move on. You can see it's sort of crazy. But let's just see. I just want to try one thing. Okay, I'll start with me, and then because sometimes because it's been trained on the internet, right? And so sometimes you get sort of odd answers. Okay, so then this is just the interactive version of it. So let's see, does it know who you are, Neve? A Camogie pen, there we go. Okay, anyway, we should stop messing around with this.
I'm sure everyone watching this is now messing around with that website.
That's right. And so anyway, so we played around with a bunch of the different parameters of the parameters of this model. And we found that there was a clear relationship between some of the parameter named temperature and the number of times that the model actually very correctly got it right. And the lesson here was, for me, always teach. I just used a bunch of terms like temperature, and you probably assume that I know what they mean. And when I wrote the paper that preceded this one, I actually fooled myself into thinking that I knew what they meant. And it wasn't until I tried to teach the material that I realized that I didn't have a clue what was going on. A lot of my colleagues seem to try to get out of teaching, and I can understand why they want to do that. But I've found that for me, having to teach has made me a better researcher because it ensures that you don't fool yourself. And the final paper that I'd like to touch on is the reproducibility of COVID-19 preprints by Annie Collins and myself. And in that paper, what we did was we grabbed a big data set of preprints posted to arXiv and bioRxiv and medRxiv and socRxiv over 2020 and the first half of 2021 related to COVID-19. We parsed those PDFs, and we were looking for texts that signaled the availability of code and data that underpinned the work. For the preprints that are in our sample, we were unable to find markers of either code or data for 75% of them on arXiv. And the results across the other ones are similar to that as well. So it is actually higher on socRxiv. And the sort of meta lesson from this one was that you always need the code that you're writing more than once. So I thought I'd just quickly write some code, download these files, and we'd be done with it. Then Annie wanted to broaden the scope of the paper, so we had to rewrite the code because she couldn't understand my code. And then we had to, sorry, she couldn't read my, she could understand it, but she couldn't read it. It was incomprehensible. And then we had to rewrite the code because we wanted to update everything before she presented the paper. And then we had to rewrite everything because we wanted to rerun everything before we submitted the paper. Eventually, we just turned the code into an R package, and that's available on CRAN. It's called Heaps of Papers. And that's what I should have done from the start. The lesson that I learned from this paper is that regardless of how certain you are, even if you're completely certain that you're never going to use some code again, you're always going to need the code again. So I'd just like to close with a few sort of three areas where I think that we need a lot of work in data sciences. Most of it's not the most exciting of tasks, but I do think that they are among the most impactful. So the first is, how do we write unit tests for data science? So one thing that working with computer scientists has taught me is the importance of unit tests. And for those of you who don't know, basically this just means writing down some small checks that we sort of do in our heads all the time. For instance, if we have a column in our data set and it's claiming to be a year, okay, then it's unlikely that it should be a character. There should probably not be any characters in there. There should not be any A's or B's or C's. And it's unlikely that it's an integer that's greater than 3,000. And it's unlikely that it's a negative integer. And we all know all of this, right? It's all really obvious, okay? But writing unit tests has us write all of this down, and it will cause errors if there's some sort of weird thing that happens to our data set such that those tests fail. In this case, in the case of the years, it's obvious what the unit test should look like. But more often, we have little idea what our results in data science are going to look like if they're running well. The approach that I've tried to take to get at this issue is to add simulation. So we simulate some reasonable results, we write our unit tests based on that, and then we bring the real data to bear and adjust as necessary. But I think that we really need some more extensive work in this area, because the current state of the art is just resulting in social sciences papers that you just basically cannot trust. The second area is, I just don't know what happened to the revolution. So I don't understand what happened to the promising machine learning revolution that was coming in social sciences. And more specifically, I've not seen any convincing application of machine learning methods that are designed for prediction to a social science problem where what I care about is understanding. And I would like to see either some evidence of them or a definitive thesis as to like why it cannot happen. And the current situation is untenable, because folks in those fields that have, historically been female are made to sort of feel inferior, even though their results and their methods are actually doing no worse. I really think that we need a lot of work in this area. And the final thing is power. So I learned statistics from economists, but now I'm partly in a statistics department, and I do think that everyone should learn statistics from statisticians. And this isn't anything against economists, but it's just that the conversations that I have in statistics departments about what statistical methods are and how they should be used are very different to those that I have in other departments. Statisticians just have this nuance when they talk about this. I think that the problem is that people outside of statistics treat statistics just as a recipe in which they follow various steps and then out comes a cake, okay? And with regard to power, it turns out that there are a bunch of instructions that sort of nobody bothered to check. They just turned the oven on to some temperature without checking that it was 180 degrees. And that's fine, because whatever mess came out was acceptable, because the people that were evaluating the cake didn't know that they needed to check the temperature. And I'm going to stop with this analogy right now, actually. And as you know, right, the issue with power is related to a broader discussion about p-values, which basically nobody is taught properly, because it would require changing how we teach statistics, and it would require moving away from that recipe approach. So my specific issue, I think, is that people think that statistics is a recipe to be followed. And I think that that's because how they're trained, especially in social sciences like political science and economics, and that's what's rewarded professionally. But that's not what I think these methods are. Instead, having spent time in statistics departments, I think that statistics is a collection of different instruments that let us look at our data in a certain way. And I think that we really need a revolution here, not sort of just a metaphorical tucking in of one's shirt. Right, so I might leave it there. Thank you very much, Neve, for inviting me. I hope I haven't bored you all too much. Merry Christmas, happy holidays. I hope that you all have a wonderful start to 2022. And I would love to take any questions.
Thank you very much, Rohan. Do we have any questions? I'll just wait for a hand up there. I was interested in your COVID paper, where you were looking for the code. Like, did you find that people were saying that they had code available and then it wasn't available, or was it just like they weren't mentioning it at all?
It was the latter. So it was very much that it just wasn't a concern. It just wasn't mentioned at all. And I was surprised by that. I sort of thought that we'd moved on a little bit.
I thought so. Yeah, I think so too. But then maybe it's more discipline specific. Like, and I also think I had a conversation recently about this with a group where we're looking at, like, talking about open research here in a minute, and it's kind of our responsibility, I think, even as reviewers, to ask for that kind of stuff now. Like every time you review a paper, just like, can you please share the code? And then it prompts people to do it, maybe. So hopefully, like, that will improve things. But yeah, it's very surprising to not even, because sometimes you see it that it's mentioned and then it's like available upon request, which is like infuriating. But yeah, it's surprised to see it's not even mentioned. Catherine, you have a question there?
Yeah, well, just to comment on the data, I think in a lot of areas that people go to a lot of trouble to collect the data, they don't really want to share the data. That's my 2 cents worth. But about your comment about machine learning in the social sciences, it seems to me that in the social science, like a lot of the survey data, the signal is it's not a hugely strong signal like you get in scientific data. So therefore, there's not really much value in fitting machine learning models, because you're not really going to get improved predictability. And like, you know, the trade-off, I mean, you really want to be able to explain. So if you can't really get much better predictions and you can't explain, then there isn't, most of the time, there isn't a benefit to fitting machine learning models in social science applications, you know, compared with, you know, kind of more, you know, scientific or hard data type problems. So maybe you have a different opinion on that. That's my experience.
No, I mean, that's exactly been my experience as well. But now we're sort of teaching all of this stuff as we're in the social sciences, and I've exactly as you're saying, like it doesn't seem to do any better.
And is it being taught in the social sciences? Like, is machine learning being taught as methods that should be used?
I mean, I do think that it is. I think if you look at for instance, if you look at recent PhDs on the market in economics, they tend to have their sort of their titles, and they'll often have sort of a machine learning approach to whatever.
Yeah, I think it's kind of like, sometimes it's a buzzword. People think if they have it, it makes what they're doing sound much better, and it's like sometimes it's just not the case. But
I think it's a bit of a fad. It's like, you know, a lot of PhDs now have causal in them, and that's another. You know, things just go in cycles.
Yeah, I think
Are we near the end of the cycle, Carl?
Let's hope so.
A couple of questions from.
Yes, James, go ahead there.
A few comments from Montreal. I think on the social science side, first of all, I think, yeah, when a psychologist told me once, and the first time I ever worked with social sciences, they were very happy when they got an R-squared of 0.19. That sort of told me what's going on. Yeah, so I agree with Catherine on that. Now, going back to your beginning stories about error back in the 18th, 19th centuries, errors, it's interesting that some epidemiologists knew the consequences of serious errors in government data. And one of the guys who was a hero in epidemiology should be also a hero in statistics, and that's John Snow. John Snow was comparing cholera rates in South London between two water companies. And he went around and had to get the numerators himself because nobody knew where their water came from. But he had a list. He then complained because the government redid the survey and came up with very much attenuated ratios of mortality between the two water companies. And the government had done a full census of the whole thing and classified everybody according to the water, but also classified the deaths. But the death addresses were taken directly from the death certificates. So you would think that a death certificate, not the cause of death, but that the address given on the death certificate would be pretty accurate. John Snow said he had to go to 3 houses to find the right death, the house where the death had been, 3 houses. And he worked out that the rate ratio he was getting was 14. The rate ratio the government was getting was 5. Of course, they were delighted because they didn't believe the theory at all about it being waterborne. So he was amazing to me, and it's still a very hard problem for our math stat people today to work out how much of an attenuation there is if the numerators are misclassified because of the errors in the addresses. So all he told us, and it's a very interesting way he told it, he said, I have to go to 3 houses usually to get the right house. And translating that into a statistical model was no easy job. But it was very clear what he meant, but it took us a long, long time to figure out how much it mattered. But he should be a hero in statistics as well, because he understood. And he eventually worked out kind of in his own way what the misclassification was doing and how much it was attenuating it. But it's a remarkable story. And I think the other thing I say is that we should not just be looking at the raw data, we should be looking at the old reports like you are, Rowan, as well. Read the originals. The original book sold 59 copies, but it has all those gems in it that our students today take for granted that, oh, the government has it, it must be right. And it's not. So
I'll be interested to see if we have a different generation of students coming. and they maybe understand your point about, if the government's got it, maybe the data aren't necessarily correct because
I hope so.
The COVID situation, right? We've sort of seen that.
Yeah, that they
governments
have no clothes sometimes. That's right. That's right. Yeah. And on one comment, if I might, on the last topic of power, you were there pushing for the idea of listening to statisticians because they kind of are the cleanest about their concepts. I guess that's how I translate what you say. But I'm worried particularly about power because I think it's taught wrong by statisticians, because statisticians are happy when they can get a delta in the sample size calculation. And they leave it to the others then to work out the delta, but they have explained it wrong. And the point of the delta is not what you'd hope to get. The delta is what would matter if it were true. The delta is a matter of judgment. And here we have statisticians telling us the delta, when in fact it's nothing about data. It's about what would matter. How much error could we have, or how much performance do we need from a rapid COVID test? Well, whatever it is whatever would make a difference and whatever would be worth spending the money on. But I think and I'm taking blame for us statisticians now who are teaching the delta the wrong way and have been for years and years and years. I'm trying to put it in a paper that I'm sending in, and I know I'm going to get whacked by the reviewers who don't like to hear this, but I think it's something we need to rearrange, and we should get rid of the delta as well, because it's a p-value idea, and get back to something normal. But anyway, I loved your stories in general.
I also loved your stories, and I think your advice about always starting small and then iterating is super useful. I'm certainly going to use that with my students, because I think it's a really succinct way to say what is very useful when you start some data analysis. So thank you for that. Okay, I think we'll let you go now. We've kept enough you for long enough. Hi to Monica, and we will hopefully see you again soon. Thank you very much, Rohan.
Thanks very much, Luke.